very kind of economically defined principles of value, which may mean things like monetary value, but also things more closely related to hedonic value, whether it's food or drinks or other things that motivate individuals. And you can tell from the title here that we're now kind of moving into a very different realm, what we call sacred values. And I'll get to that in a minute. Before though, I want to thank all of my co-authors and collaborators, most of whom are here, Mike Matula and Monica Capra, and in the business school in economics, and Emily Bell, somewhere here in the audience, who's actually doing all the hard work. The other two authors, Jerry McGingus and Scott Atran, are collaborators, which really kind of got this project going, actually, when I heard one of Scott Atran's talks. Atran is an anthropologist who studies terrorism, and I heard him speak at a program review for the Air Force, which I was attending just as a spectator to see exactly what the Air Force, the Defense Department, is doing with some of the money. And all of this actually began, this is Secretary Gates, Robert Gates, Secretary of Defense. So for those of you who don't know about this, I think this is very interesting and kind of gets to the heart of what we're studying. So about 2 years ago, or 2.5 years ago, Gates launched something called the Minerva Initiative, which was essentially the Defense Department's public statement. And so let me read this, actually, I have a hard time reading it too. And their interest in human behavior. And so what it says is, America today faces more challenges from more varied sources than at any time in the recent past, from the rise of powers to ethnic strife, disease, and poverty, from climate change to failed and failing states, and the rise of violent extremism. The United States increasingly will be forced to grapple with unprecedented social change. To address these challenges, Americans and their government need a better understanding of the factors and causes behind these changes, what they might mean for the United States, and what the future might bring. And so the DoD's Minerva Initiative is intended to help develop that understanding by drawing upon the knowledge, ideas, and creativity of the nation's universities. So it was actually a very interesting and controversial statement. It was interesting because it represents an entirely new direction for the Defense Department. It was greeted with varying degrees of welcoming and hostility depending on how people feel about the Defense Department and their interest in human behavior. And there's obviously been a checkered history in this realm. But needless to say, I was impressed by this statement, and actually impressed by talking with many of the program officials, both in the Air Force and the Navy, who ultimately came to fund this work. And my sense was the motivation is actually genuinely good, in my opinion, for a greater good. Really what many of the program managers and the military people tell me is that they realize perfectly well that it does no good to blow up villages in third world countries, because that just creates more terrorism and more backlash against the United States, and nobody really wants to be doing this. And yet they have no tools to really understand the biologic and sociologic motivations behind people's behaviors that fall kind of in this extremist realm. And so it was kind of with this backdrop that I began talking with the anthropologists and social scientists to try to understand what they knew and whether we could actually understand extreme behavior from a biological perspective. Because my perspective is first and foremost that behavior originates in the brain and is therefore fundamentally a physical and biological process that we can study. So having said that, you can realize that there are challenges to this. So kind of in the next 20 minutes, I just want to hit on 3 points on our approach. Now, most of this work is not published because it's actually only been funded for a year, and we're just completing the first work in sacred value study. I'm going to talk about 2 studies that pertain to this. The 3 points, though, that I want to hit on, first is, what does neuroimaging measure? I realize from this audience that most people here are neuroscientists and probably know the answer to this, but it's always worth reiterating because that's what we use. The second point ultimately becomes very important when you're talking about practical applications. And this work kind of falls into the intermediate realm of not quite practical, but it's also not quite basic either. And that is, can you use brain activity or neuroimaging to predict behavior? We are, after all, trying to understand extreme behaviors and ideally prevent them. So that requires some level of forecasting and prognosticating. And then finally get to the work on imaging of sacred values. All right, so why neuroimaging? Ultimately, we're interested in what people believe. Why do we care about what people believe? Well, if we're reasonably rational and reasonably consistent, our beliefs have something to do with what we say, but more importantly, with what we do. Now, the problem with this picture here is that if you want to know what someone believes, in fact, these are the only 2 ways you have access to them. It's either what they say or what you observe that they do. And they're not always consistent. And these are not always consistent with each other. And they may or may not always be consistent with what a person believes, as well as the fact that beliefs can change over time. Well, for the most part, these can be reasonably good measures, apart from the occasional times when people are irrational. The circumstances where they're not, though, are when the beliefs are either socially sanctioned, i.e. they're illegal, or it's known that they're not popular beliefs, or any other variety of circumstances you can imagine where people are not willing to talk about things, or necessarily reveal what they do. So this is in kind of interesting realm of kind of public and private behaviors and public and private statements. Well, why does the military care about this? The other circumstance where these actually kind of break down are for things that haven't happened yet and for which there is no track record. Either a person hasn't said anything or hasn't done anything. And so that brings us into things like terrorist acts. And I put this one up because, again, it's the 15th anniversary of the Oklahoma City bombings. And did anyone actually watch this special on MSNBC this week on Timothy McVeigh? They actually released some audio tapes that he recorded before he was executed, and which, as far as I know, are the only record of him admitting to the bombing. And what's very interesting about these tapes is the rationale that he gives for it. Very matter-of-factly, what he viewed was contributing to the greater good, as he saw it, which at the time was feeding into kind of an anti-government movement. One thing that I learned that I didn't know is, or I had forgotten, that the date he chose had 2 meanings to him. One was the anniversary of the Waco incident, and the other one, as he said, was the shot heard around the world in the formation of this country, so like 220 years ago. Important events in his mind, but the reason we're going after things like this is because there was no clue what was going on in his mind. Clearly he had beliefs. He didn't voice them except to a couple of people, and there was no indication of what he was going to do until it was done. So the practical applications, I think, are fairly profound. Now, I always put this slide in just to point out that there are many levels when we start bringing biology into the study of behavior that we might study this. We're going to be focusing on systems and how these interact with beliefs and society as well, and how these interact with each other. But there are other levels, including the genomic level as well as the cellular level. Thankfully, I can do this quickly, I think, with this audience, just to remind people what it is that we're measuring. So we're using functional MRI to measure fundamentally blood flow changes. And I like to put this slide up because this is actually, as far as I know, the first drawing of a brain imaging experiment. It was drawn by Angelo Maso, an Italian physiologist who invented the blood pressure cuff, which is right here. That is the first blood pressure device. And Maso had used this device primarily to measure peripheral blood pressure, but one day he had the rather brilliant idea of attaching it to someone's head. And this guy here, his name's Bertino, was not any old guy walking around the Italian streets. He was a stonemason who had suffered a skull fracture when the stones had fallen on his head. And he survived, but he always had a defect in his skull. There was a hole in his skull covered by skin, providing a window onto his brain. And Maso had attached his blood pressure device to that window and observed the pulsations in the brain underneath. And what they observed was that the amplitude of those pulsations changed depending on what Bertino was doing. And the story goes, at least as it was written, that they were doing this one day and the pulsations started getting very large. And he asked Bertino what he was thinking, and he said, well, I heard the bells in the town square go off, and it reminded me that I did not go to church this last Sunday and I'm overdue for confession. It's an interesting story. It could be true. It's kind of a nice illustration because you can see from the placement of the probe that's on the frontal lobes, and that's consistent with what we now know and believe about frontal lobe function and executive control. Nowadays, we essentially do the same thing, but we use magnetic fields to detect changes in blood flow, relative changes in oxygenated and deoxygenated hemoglobin. And all of this is banked on the fact that neural activity, primarily synaptic activity, is correlated with these changes in blood flow. All right, so the first question and the first study that I want to tell you about is work that we did several years ago. This has nothing to do with sacred values, so I'll tell you that up front. It's much simpler and gets at the question of whether you can use brain activity in any form, in this case functional MRI. Can you use it to actually predict behavior? So let me describe the experiment and then interpret it for you. So this was an experiment initially designed to look at how negative incentives influence behavior. So what's a negative incentive? Well, in economics, it can be losing money. Turns out that it's rather difficult to design an experiment in which people lose money. It can be done with a lot of extra effort, but the basic problem is you can't bring people into an experiment in which they end up paying money to participate. It violates all sorts of ethical guidelines and IRB rules. Because that is, in essence, what has to happen for somebody to lose something. One way around that is another way to study how kind of the prospect of something bad happening is to use brief electrical shocks, which is what we did. People don't like them. You can titrate it into the realm in which it's mildly uncomfortable, but not so much so that people are going to yank the electrodes off. If anyone wants to see this in action, I'm actually doing another symposium tomorrow on dread, where I'm calling out the shock apparatus. So what this experiment was about was what we kind of familiarly call gambling for shocks. The idea was that how does an individual incorporate elements of probability, predictability, with the prospect of something bad happening? So in other words, do people prefer a low likelihood of something unpleasant, really unpleasant happening, or a high likelihood of something not quite so unpleasant? And in terms of our experiment, simply do people prefer a high probability of a low voltage shock or a low probability of a high voltage shock? There's no right answer. These are personal preferences. And what we were interested in initially was, how does the brain represent probability? How does it represent the outcome of these painful events? And how does it integrate these things ultimately to form a decision. So the way we set up the experiment was that we presented these things as lotteries. We measured the fMRI response to the lotteries in which we're varying two things, the magnitude of the shock and the probability of the shock independently. We identify regions that correlate with these two dimensions. Then the idea is that we look at individuals' actual choices. So keep in mind there were 4 levels of shock amplitude and I think 5 levels of probability for a total of 20 combinations. And essentially we offer these choices. High and low probabilities, high and low magnitudes. We make the choices. And then we ask the question, is there something about the brain activation when we're just showing these lotteries that allows us then to predict what a person will choose when given freedom of choice? So this is what the experiment looked like. In the passive phase, we showed, this is how we represented the lottery, where the size of the disc represented the magnitude of the shock that was up for grabs, reference to their maximum tolerable level, which is the gray circle. And then the red portion just represents the probability of getting it. So this is a cue that says a 1/3 probability of getting, say, a moderate level shock. So you see that, they wait, and then we roll a virtual dice and they either get shocked or not. Then later in the experiment, we offer them choices like this. So this would be a 1/6 probability of a high level shock, almost to their maximum, versus the 1/3 probability of a lesser shock. So again, you have to decide how you're trading off likelihood and voltage. So these are lottery tickets for shocks. They make their choice, and then again we roll the virtual dice. What we can then do is go and correlate in the passive phase the regions of the brain that showed linearly varying activity with either of these dimensions. In red are the regions that varied with the magnitude of the impending shock. So this is all they're weighting, not what they actually get. And then the probability of getting it. Generally, I'm not going to interpret these maps. Just point out that they're largely different but overlap in certain regions like the cingulate gyrus and the supplementary motor area, we think. That's not the interesting part of this experiment, because I want to talk about the predictability part. These regions then give us kind of a roadmap to look for the parts of the brain that might be useful for prediction, because we now know these are the parts that are coding the relevant information. So what we did was we went in and in each of these areas define what we call a region of interest, an ROI, and extract the activation levels for each person in each of these regions, each of the 20 different combinations of probability and shock magnitude, and then put them into a model of choice. And so that's what this looks like. This is just the math of it. So what we're saying is that we can put them into a model. This is called a logistic choice model. It's just a way of taking continuous variables like this and coming up with a function that's is essentially binary. So what we've done is, if you're faced with this choice here, what's the probability of choosing the one on the right? And so we just take the values that we got out of the person's brain in these regions, plug them in to the left and right side, take the difference, and we do a regression. And the way we do this is, there were 60 trials for each person in this experiment, so we run a regression on 40 of those trials, and then use that model to predict on the remaining 20. So it's a standard kind of bootstrap procedure where you use some and leave some out to test. Okay, so how well does it do? I wouldn't be telling you this if it wasn't an interesting answer. How well it does depends on what you're comparing it to. So what would be the natural thing to compare it to? The natural thing would be what a person has previously chosen. So can you take out of those 40 trials a person's choice and then predict what they do on the remaining 20? The way we did it was in this graph on the x-axis. So you can imagine constructing a rank-ordered list of these things, these lotteries, based on a person's choices, from their least favorite to their most favorite. And for any pair of those, compute a ranking difference, which is this. So lotteries that have a low ranking difference, 0 for example, means that sometimes they chose one, sometimes they chose the other, and they're essentially indifferent to the two. Which by definition means that their past behavior is completely useless for predicting future behavior, because sometimes they pick one, sometimes they pick the other. It turns out that it's in precisely those circumstances, so that that's our dashed line there. The solid line is the brain model. It's precisely in those circumstances where the brain data can be used to predict a person's choice, even when their past behavior is worthless for that. So this is quite interesting from a practical perspective. It's also very interesting from kind of more of a basic science perspective. It means that the brain apparently has representations of information that go into decision making, but for reasons we don't fully understand, maybe due to noise, maybe due to other things, they don't kind of always come out with high fidelity. And it's actually consistent with what we call a probabilistic choice model, where all our decisions, to some degree, there's some uncertainty. You don't ever know exactly what you're going to do. It's like the brain's just flipping coins at some point. But if you have access to enough of those kind of virtual coins in the brain, you can actually do better than a person themselves. All right, so the point is, you can predict behavior in very specific circumstances. So I think that there is some real utility and possibility here. And so given the nature of this symposium, you're probably wondering whether we should do that. I'm not going to answer that question right now. So that's predicting behavior. To get into the sacred values, I became very interested in this area because it's also clear that a lot of important human decisions are not based in material and financial incentives like money and shops and food and sex and all the things that we think motivates humans. In fact, humans are rather unique in the regard that the last thing on there is that our behavior can be guided and influenced by abstract beliefs. So an abstract belief that I'm talking about are things like religion, to some degree national identity, to some degree race. All the things that kind of fall in these categories of topics that you don't generally talk about with your in-laws, but are very powerful determinants of what people do. And you don't have to go very far outside of the university campus to appreciate how strongly some of these beliefs guide people's behavior, and sometimes how arbitrarily, I'll just leave it at that, how arbitrary some of these beliefs are. Okay, so now we get to the experiment that we're actually doing right now. So I'm just going to run through this. This is one of our simplest stimuli. So how can you possibly measure whether someone believes in God or not? You can ask them, but to me that's not very insightful. If you were resourceful, I suppose you could follow them and see if they went to church. And maybe if you were more resourceful, you could give them some kind of thing